All right, buckle up, everybody. We're diving deep into one of the most famous thought experiments in physics, Schrodinger's cat.
Oh, yeah, this one's a classic.
We're going to be looking at excerpts from chapter 23 of Schrodinger.pdf
Okay.
to try and unpack some of this quantum weirdness.
Right.
And you know what's interesting about this thought experiment is
Yes, that.
it wasn't actually just about, like, a cat stuck in a box.
Well,
It was actually a kind of a critique of how quantum mechanics was being interpreted
interesting.
at the time.
Yeah, you see Schrödinger and Einstein, too, actually.
Oh.
They weren't super comfortable with a universe that was, based on probability and chance.
Right.
They much preferred this idea of a deterministic universe.
Okay.
And quantum mechanics, all of its, inherent uncertainties,
Yeah.
really challenged that worldview.
So they weren't actually trying to prove that a cat could be both
Right.
alive and dead at the same time.
Exactly.
They were trying to point out what they felt was maybe a flaw in quantum theory.
Yeah, they were basically saying,
Yeah.
hey, if we take these quantum principles, to their logical extreme,
Right.
we end up with these absurd scenarios, like a cat being both alive and dead at the same time.
Yeah. Okay.
And it all really stems from this concept of quantum jumps
Okay.
that was being debated, back then.
Ah, quantum jumps. Now, wasn't that something that Niels Bohr proposed?
He did. He was a major proponent of this idea that electrons in an atom
Okay.
could suddenly jump between energy levels, not gradually, but just like
Oh, wow.
instantaneously, like boop.
Okay.
And this was a key part of his quantum theory.
But Schrödinger wasn't convinced.
Not really? No.
He preferred a more, like, continuous,
Exactly.
a wave-like description of reality, right?
Yeah, he felt that Bohr's description of these quantum jumps was incomplete,
Okay.
and that a more continuous, like you said, wave-like behavior, like what he described in his famous wave equation,
Right.
was a better representation of, how the physical world really works.
Okay, so we've got Schrödinger and Einstein kind of questioning these quantum jumps
Yeah.
while Bohr is championing them.
Yep.
And then this debate ultimately led to Schrödinger's cat.
It did. But before we can really get to the cat,
Okay.
we need to talk about superposition.
Okay, lay it on me.
This is where things get really interesting.
I'm ready.
Okay, so imagine a coin, right, spinning in the air
Yeah.
before it lands.
Okay.
Until it actually falls, it's technically neither heads nor tails, right?
Right.
It's in this weird, uncertain state where it could be either.
Yeah.
So that's kind of the idea behind superposition
Okay.
in quantum mechanics.
So particles can basically exist in multiple states at once until we measure them.
Well, it's not quite that simple, actually.
Okay.
It's more accurate to say that a particle's state is kind of undefined
Okay.
until it's measured.
Okay.
We often confuse superposition with this idea that the particle is
Yeah.
literally existing in multiple states at the same time.
Mm-hmm.
But, quantum mechanics really deals with probabilities,
Oh, okay.
not literal, like dual existence. You know what I mean?
Okay, so it's more like saying that the spinning coin
Yeah.
has a certain probability of landing on heads.
Right.
And a certain probability of landing on tails.
Yep.
It's not both at the same time.
Right.
But we just don't know which one it's going to be.
It's all about like the uncertainty of its final state,
Gotcha.
and this whole concept of probability rather than
Okay.
it actually existing in both states.
Yeah.
That's really important to understand for Schrodinger's cat.
Okay, so how did we get from probabilities to cats, though?
Well, Einstein, always a fan of a good thought experiment,
Yeah.
he came up with this analogy
Okay.
to try to illustrate this concept of superposition.
Okay.
Imagine a box with a radioactive atom in it,
Right.
and this atom has a 50-50 chance of decaying
Yeah.
in a certain time frame.
Okay.
And if it decays, it triggers a device that sets off a bomb.
Whoa. Okay.
The point is, until we open that box and actually look at the atom,
Right.
it's in a superposition of states.
Okay.
So both decayed and undecayed.
Okay.
And because that bomb is linked to the atom,
Mm-hmm.
it too is in a superposition of states, both
Interesting.
exploded and unexploded.
Okay. But like you said before, with the coin, it's not that the bomb is actually in both states at the same time, right? It's that we just don't know which one it is.
Yeah, our knowledge is uncertain until we actually make that measurement.
Okay, so where does the cat come into play in all of this?
So Schrödinger basically took Einstein's bomb analogy
Okay.
and replaced it with something a little bit more feline.
Okay.
Imagine now a cat sealed inside this box
Mm-hmm.
with a radioactive atom
Okay.
a Geiger counter to detect if it decays,
Right.
a flask of poison gas,
Oh, no.
and a hammer.
Oh, jeez.
So if the atom decays, the Geiger counter triggers, releases the hammer, which smashes the flask,
Oh, my God.
killing the cat.
Wow.
Yeah. Not a great scenario for the cat.
That sounds kind of rough for the cat.
Yeah, it is.
So if the atom is in a superposition of states,
Right.
does that mean the cat is also in a superposition?
That's exactly the point that Schrödinger was trying to make.
Oh, okay.
He was using this thought experiment
Yeah.
to highlight what he felt was a potential absurdity.
Okay.
When you apply quantum principles, specifically this idea of superposition,
Right.
to the everyday world, the macroscopic world.
So he wasn't actually saying
No.
he believed that a cat could be both alive and dead at the same time.
He was being provocative.
Right.
Yeah, he was trying to get people to really think about
Okay.
how we interpret quantum mechanics,
Yeah, so the cat is not some kind of quantum zombie.
No, not at all.
It's just meant to highlight.
Yeah, it's a tool
Okay.
to highlight the potential limitations
Okay.
of applying these quantum principles to our world.
So how does the probability thing actually play out in this scenario?
That's where the visuals from our source material come in handy.
Okay.
They show how the probability of finding the cat alive or dead, changes over time.
Okay.
For example, at, time t divided by 2,
Right.
there's like a 75% chance the cat's alive
Okay.
and a 25% chance it's, not.
Right.
At time t, it's 50-50.
Okay.
And then at 2 times t,
Right.
it's flipped. 25% alive and 75%.
Not alive.
Yeah.
Okay.
But the key takeaway here
Yeah.
is it's always about the probabilities, not about the cat literally existing in
Right.
some kind of blended state.
So the cat isn't morphing between life and death. It's
Right.
more like the longer we wait, the higher the chance of the cat not being alive when we open the box.
Precisely.
Okay.
Schrodinger's cat is not about like a cat defying biology.
Okay.
It's about making us think about how we interpret this probabilistic nature of quantum mechanics.
Okay, I think I'm starting to wrap my head around this.
Good.
But I feel like there's still more to uncover here
Oh, yeah, absolutely.
with this quantum cat conundrum.
Definitely. And this is where things get even more interesting.
Okay.
The source material dives into this concept from information physics,
Okay.
suggesting that the cat itself, or even just the Geiger counter,
Okay.
could actually be considered an observer.
Hold on. Are we saying that the cat is like observing its own potential demise here?
Not exactly.
That seems a little too meta, even for quantum mechanics. I don't know.
It's not really about consciousness,
Mhm.
in the way that we typically think about it.
Right.
Information physics basically proposes this idea
Yeah.
that the creation of information within a system
Mhm.
is actually what makes a measurement.
Oh.
And that measurement,
Yeah.
that's what collapses the wave function,
Right.
causing the system to go from this, superposition of states
Yeah.
to a definite outcome.
So it's not about a conscious observer actually looking into the box.
No.
It's about the information being generated within the system itself.
Yeah, exactly.
Okay, so whether that's the cat, meeting its unfortunate end,
Right.
or the Geiger counter clicking, or even just, I don't know, maybe a temperature change inside the box.
Yeah.
That creation of information is what solidifies the outcome.
Right, exactly.
But the universe is constantly kind of observing itself, encoding information.
It's a cool way to think about it.
Yeah.
The source material even uses this analogy of a pen chart recorder
Okay.
attached to the Geiger counter.
Right.
So even without a human scientist, there to actually look at it and interpret it,
Yeah.
the recorder is creating this physical record of the decay event.
Huh.
And that record, that information, is enough
Wow.
to solidify the outcome.
Okay, so the cat isn't both alive and dead at the same time. It's that the lack of information creates this illusion of superposition.
Exactly.
And then the creation of information within the system,
Right.
regardless of whether a human is there to see it,
Doesn't matter.
is what collapses the possibilities into a definite outcome.
That's a great way to put it, yeah.
Okay.
And the source material, takes this idea even further,
Okay.
pointing out that even without, a fancy recorder,
Right.
the cat's body itself
Uh-huh.
acts as this information store.
So like a biological record of the event?
Precisely.
Okay.
Like a forensic scientist could, in theory,
Yeah.
examine the cat's remains
Right.
and determine, the time of death.
Oh, wow.
Essentially, reconstructing the event from that information encoded in the cat's biology.
That's kind of a morbid thought.
Yeah, it is a little bit.
I guess it makes sense.
It really drives home the point
Yeah.
that information is really key here.
Right.
It's not just about, observation in the traditional sense. It's about the creation and the preservation of information. That really defines the reality of the situation.
That connects back to something we were talking about earlier, right?
Yeah.
About these alternative possibilities.
Exactly.
Remember how Einstein and Schrödinger and some other physicists were really troubled by this?
Yeah, they were.
Inherent randomness of quantum mechanics?
They really longed for that deterministic universe.
Right, where cause and effect
exactly
makes sense.
Yeah, where everything's predictable, unfolds like clockwork.
Right.
No room for this quantum fuzziness.
Right.
Yeah.
But this whole thing about information as a measurement suggests that maybe the future is indeterministic.
Could be, yeah.
At least until information kind of solidifies it.
Right.
It's like the universe exists in this state of like potentiality.
Yeah, like a swirling cloud of possibilities.
And then the creation of information, it's like it crystallizes those possibilities into a concrete past.
Yeah, exactly.
And determines the course of events.
That's a really cool way to think about it.
So we're not just talking about a cat in a box anymore.
No, we're not.
We're talking about like the nature of reality.
Yeah.
The flow of time. How information shapes our understanding of it all.
Right. Schrodinger's cat, at its core,
is
a thought experiment that really forces us to confront these fundamental questions.
Yeah.
About the nature of reality.
Right.
The role of information. And how we make sense of the universe.
Right.
That often defies our everyday intuition,
Yeah, when we started this whole deep dive, I honestly thought it was just going to be about, a quirky thought experiment.
Fun little thought experiment.
But it's really opened my eyes to how profound these implications of quantum mechanics are.
Absolutely.
And the role of information in shaping our reality.
Yeah. It really makes you think.
Yeah, it does.
It's a testament to the power of these thought experiments.
Okay.
To challenge our assumptions and push the boundaries of what we understand. They can really lead us down these unexpected paths.
Yeah.
And illuminate aspects of the universe we might never have even considered otherwise.
Absolutely. We've gone from, debunking the myth of the zombie cat to exploring the importance of information in quantum measurement.
It's a journey.
And even pondering the nature of time and causality.
Yeah.
What else is there to uncover?
I don't know. There's always more.
With this quantum cat conundrum.
You never know what you're going to find.
Okay, so we've debunked the whole zombie cat thing.
Right.
And we've kind of talked about how it's really the creation of information that solidifies the outcome.
Exactly.
But this whole discussion about information as the observer has got me thinking.
Okay.
Could this actually point us toward like a solution to the measurement problem?
Oh, that's a great point.
With quantum mechanics.
Yeah, the source material actually touches on that a little bit. So for those who maybe need a refresher, the measurement problem is it's one of the biggest head scratchers in quantum mechanics.
Okay.
It basically asks, how does the act of measurement cause a quantum system to collapse from a superposition of states into a single definite outcome?
Right. It's like the universe is waiting for us to look at it.
Yeah, exactly.
Before it decides what reality is going to be.
Yeah, it's like, oh, you're looking now? Okay, I'll decide.
Yeah, exactly.
And for a long time, people thought that a conscious observer was crucial for this to happen.
But the idea of information as the observer kind of throws a wrench into that, doesn't it?
It really does, yeah.
So instead of, our minds collapsing the wave function, it's actually the creation of information.
Right.
Regardless of who or what creates it.
It doesn't matter if it's a person or a cat or a machine.
Yeah.
The information itself is what matters.
So Schrödinger's cat may not just be about how weird quantum mechanics is.
Yeah.
It's actually hinting at a solution to one of the biggest mysteries.
It could be, yeah.
In the field.
It's a really interesting way to look at it.
Yeah.
And the source material takes it even further.
Okay.
Remember how Schrödinger originally set this whole thing up? He assumed that the superposition of states in the microscopic world, like with that atom, could kind of be directly magnified to the macroscopic world.
Right, which is where we get the cat that's both alive and dead.
Right. But what they're saying is that that's not actually how it works.
Okay, so there's a difference between how quantum systems behave and how macroscopic systems behave.
Yeah, they're saying that that kind of coherent superposition of states that we see in the quantum realm,
Okay.
it just doesn't happen in the big world.
Huh. Okay.
Like in the quantum world, you have these crazy superposition, these interference patterns. But in the macroscopic world,
Yeah.
things tend to settle into more definite states, you know?
So the cat isn't both alive and dead. We just don't know until information is created.
Yeah, and the creation of that information, it's like a bridge between the two.
Oh, okay.
Between this weird quantum world and the world that we see every day.
This is all so fascinating, but I still have one question.
Okay, what's that?
If the universe can be its own observer, creating and recording information, does that change how we think about consciousness?
Ooh, now that is the million-dollar question, isn't it?
In quantum mechanics.
Yeah, and the source material doesn't really give us a definite answer.
Okay.
But it does suggest a pretty big shift in how we think about it.
Okay.
If the universe is always observing itself, always recording information, maybe consciousness plays less of a role than we thought.
So maybe the measurement problem isn't about our minds collapsing the wave function. It's about information itself.
Maybe. It's a really interesting thought.
It really is.
It makes you rethink the relationship between the observer and the observed.
Right.
Between mind and matter, even.
And it all started with this thought experiment about a cat in a box.
It's amazing where a simple thought experiment can take you.
Well, there you have it, folks. That's it for today. Schrodinger's cat.
More than just a thought experiment.
It's a gateway to some of the deepest mysteries of quantum mechanics.
Yeah, it makes you question everything.
It makes us question the nature of reality, information, consciousness.
Really gets the brain going.
It really does.
Yeah.
I don't know about you, but this deep dive has left me with a lot to think about.
Me too. It's always the questions that matter most, you know?
Yeah, it is.
And I think this deep dive has definitely given us a lot of those.
So as you go about your day today,
yeah,
think about the information you create.
The measurements you make.
How these simple actions might be shaking the very fabric of reality.
It's mind-blowing when you think about it.
It really is.
Yeah.
So until next time, keep exploring.
Keep questioning.
And keep diving deep.
See you next time.